All right, so thank you to our sponsors, P&G, Kroger, First Financial, Taft, and KMK. We really appreciate their sponsorship, and excited for Enrique to get started in just a minute. I want to encourage everybody to go ahead and type any questions you have in the chat, or feel free to turn on your camera instead of it being off, and feel free to ask Enrique questions live. We would love the engagement and interaction. And then we'll put at the end a survey in the chat and ask you to complete a survey at the end. So Enrique, I'll let you go ahead and take it away on what is machine learning.
Sounds good. Thank you so much. Pleasure being here. I can present to you all. So just kind of like very quick on like who am I? You probably never heard or never seen my name before. So my name is Enrique Aveiro. I currently work as director of like machine learning AI for a small startup called Insight AI. For prior to this job, I worked for about 7 years for Procter & Gamble, one of the sponsors, where I work as like individual contributor and like manager across both of their R&D and IT data science organizations. So I have built myself like models for computer vision, natural language processing, and applications in like marketing, sales, etc. And I also have like managed teams of like machine learning engineers that went into developing, bringing to life some of those solutions. A long time before that, before I joined P&G, when my hair was still not gray, I got my PhD in electrical computer engineering from Cornell University. And as soon after that, I did like a little stint for the US Naval Research Lab as a postdoc. So what do we do at Insight AI? And what does Insight AI does as well? So our company is like working on creating machine learning AI solutions for both consumer goods and retailers. And are solutions for like automating decision making or providing recommendations to the CPG, which product carrying on the shelf, which products they should be changing, such that they maximize their sales, their profitability, whatever KPI of interest they want to improve. Insight AI is a small company. So let's talk about like a few cases that are more associated with the large companies in the top tech space. So like a few examples of like machine learning that you have probably seen in I would say like in your day-to-day life might be facial recognition. So if you have like an iPhone or the type of like phone that has a facial recognition, you want to unlock your phone, there's a machine learning model there that is identifying like some of like the feature of the facial features and identify if you should be unlocking your phone. If you work in the marketing space, or if you are going to be doing marketing for your startup, you probably have seen like Facebook audiences, where you can start with like a seed audience or like a basic profile on some of the people that you want to display ads. And Facebook has those like lookalike models, which are pretty much trying to find like people that are very similar to these like seed people that we're looking for, such that you can maximize the reach of your Facebook campaigns. If you have used Google, and everybody has used Google at this point, whenever you are like searching for like a given topic on Google, and Google is providing with recommendations on what are like the best links for you to go and read material. You have like machine learning models that are piping those solutions, but there are even like other side machine learning models that are running when you are like doing like a Google search. So whenever you are like typing a search and you see that like auto completion, that's one type of like machine learning model. Also, whenever you type something, there's a typo, and then you see a response back from Google, did you mean this other thing? That's also another like machine learning model that's providing you with that level of recommendation. Other example that you probably have seen is you go to Amazon, you are looking for a product. It can be like a book on like machine learning and AI. It can be a book on like any topic, like startups, lean startups, etc. If you scroll down, you are always going to find the recommendations for like other like similar books that you should consider. So this is also this type of recommendation engine is also another type of like machine learning solution that is powering it. And finally, if you are wealthy or somebody wealthy in your family, and you have seen like the self-driving modes of like Tesla cars. There's also like a computer vision model, an AI model that is detecting all of like the features, all the objects that are along the road, and provide the recommendations to the car on how it should be moving or how it should be driving as well. Here, like on the screen, like except for like Apple, all the other cases here, like those companies are accumulating a ton of data on you or I would say on unidentified like users or on the road or the type of behavior that allows like the model to improve over time. So every time that we're, I would say, putting some of information like on Facebook based on like your profile or based on some of your comments, that information is saved and is used to improve like those models. The same thing applies to Google, like based on your search, Google tries to fine tune the results of your search based on your region, based on your location, or even based on your profile if you are logged in with your Gmail account. Similar thing applies to Amazon. Every time that you are going and they are providing recommendations and you are clicking on some of those products, that is used as some type of feedback to improve that engine. And of course, with like this Tesla example that I have here on the upper right-hand side, every time that the car is driving, is detecting objects, and you are driving, it's not on self-drive mode, but like you are driving the car, there's some type of like feedback that the model is understanding what are the actions that it should be taking, given like I would say the given state of things that is seen in front of it. So data is a very, I would say, very important piece of the puzzle for those companies to be, I would say, the top tech companies they are right now. Data is just one piece, of course. There's also like the machine learning side. So if you haven't like, you probably hear like about like machine learning in the media all the time or AI, but let's start from like the basics and talk a little bit about some of like the basic definitions of machine learning and the types of problems that it solves. So I just got like a generic definition from Wikipedia on what machine learning is. But at the end of the day, like machine learning is this like process or this study of computer algorithms where you want to be able to automatically identify what's the label, what's the action that you want to take based on like a given state. And you want like your model, your solution, this machine learning model to learn from some of like the experience like based on the data you have. So for instance, when the Amazon is recommending your products to purchase, it's basing that recommendation on the historical sales and the historical behaviors of people on their website. If I had a machine learning model that was detecting spam, email spam, somebody would need to have annotated data before with all the different emails that were spam, and a machine learning model was trained to detect what is a spam, what's not a spam. And then that model is, of course, once that model is trained, and understands like all the patterns on the data, that model is good and generalizable and good for use like across, I know, everybody's like email boxes. But that's really like a very generic definition of like machine learning, as you can see here. But like machine learning is actually, actually I heard so the other side, but like machine learning is just kind of like, we're going to be talking about like a few examples, detailed examples of like machine learning in a few slides. But when you think about like why machine learning is like so big like right now, there is like one major reason. There's like a bunch of like things or like a bunch of like building blocks that need to be happening in parallel for you to be able to do like machine learning AI and have like very good quality models. So the first one of those building blocks is data. As I mentioned in that previous slide, those companies are like amassing a large amount of high quality data every time that you are browsing, every time that you are posting something online, or every time that somebody is driving a car. So high, good quality data, large volumes, like volume, like variety is very important. The second is computing power. So in the last few years, there has been like several advancements in the types of hardware that you use to do some of those computations, either with like higher speed or doing like computations with large volumes of data that have improved. They have improved and have enabled machine learning AI. And of course, finally comes like the algorithms. So all the machine learning code or all the software that has been created in the last few years or in the last like decade that allow you to do like operations like with like neural networks, artificial intelligence software, etc. But keep in mind that all those three pieces are important for us to have had like this such an advancement of like machine learning in the last decade or so. We'll go into the detail for each one of the building blocks here. So the first one is data, of course, like the first item that I had in my list. As you're thinking about your company, it's very important that you understand what are the data that you can find available and that you can use. There's actually a ton of like open data sets that are available online, which means that you don't need to go and create your data sets from scratch. So for instance, if you wanted to create a solution right now to predict if a rating and review from Amazon was going to be like positive or negative, or what would be the star rating in a scale from like 1 to 5 stars, there's actually, Amazon has made that type of data set available, so you can go download those data sets and use for your applications. Similar thing, let's say if you're working on applications that are associated with weather data. Weather data is like another data set that you can find available in weather.gov or other websites as well. So there's like a ton of open data sets that have been made available online by several companies or by NGOs or even by governmental institutions that you can leverage for your startup. The second is you can actually create your own data sets. So depending on the type of data set that you need to create, you have different options. So you can pay a fee to a human, to a person to go and annotate your data. So let's say you had a set of images and they were associated, let's say, with animals. If there was a cat, dog, or a horse, and you need somebody to go and annotate those initial images, provide a label to those images, such that you can use that high quality data to train a computer vision model to automatically detect which type of animal you are seeing on a picture. So you can use Amazon Mechanical Turk, just one of these type of services where you pay a small fee to annotate the image, the label is, and of course, those images for training your models. Specialized allows your team to do it themselves. You can create a new high quality data sets as well. So this example that I had here is just like you're creating like small volumes of annotated data in high quality data sets. But creating a high volume and high quality data sets is quite expensive. So this is something that's really hard to do. And that's why you see several of like those companies, like my previous slide, Amazon, Google, Facebook, Alibaba is another example here, as being like some of like the companies that are leading this space, both on the computational side. So for instance, Google has brought to life like a platform for doing machine learning called TensorFlow. Facebook is like one of the major sponsors of another platform called PyTorch. So they are fostering, I would say, like creating a community that goes and improves like those machine learning software that allows you to train your models. But at the same time, they have like a very large volume of like a large volume of high quality data sets. And that's some of the reasons why those top tech companies are winning the market. So as you think through your journey in your startup, as you are founding your company or think about your business model, try to think about ways where you start with a small data set, but over time you keep accumulating data such that you can keep improving your models. That's really key here, and you can see that that's actually a piece of the business model of several of the companies that I have here on my screen. The second one is computing power. So computing power can come like in two different flavors. So the first piece is the advancement in technology. So in the last decade, there has been several advancements with graphical processing units. So here you see AMD and NVIDIA are two of those large manufacturers of GPU cards. So those are, let's say, cards like processing units that you would put in your computer. And in the past is the type of like processing unit that would accelerate the computation of like the graphics if you were a gamer. Over time, people identified that, yes, they were very good for doing those computations for 3D translations of objects or like people like first shooter games, etc. But they were very good like to doing accelerated computations of like matrices and tensors, some of the things that are needed to do like very high quality and high volume in large machine learning models as well. And then in the last few years, the last couple of years, Google has introduced the tensor processing unit, like the TPUs, which is this type of card that you have here, which you can almost see as kind of like some type of like variation of those other GPU cards that I have here on my left-hand side. So those cards are very good for the computations. So they with gamers became popular in the machine learning space. And then lately, not lately, but like in the last few years, they became very popular if you are doing a cryptocurrency mining as well. So they're very efficient at some of like the computations needed for like mining Bitcoin, for instance. But this is just like one part of like the puzzle. Those cards can get very expensive. So some of those GPU cards, they can be like more expensive than $5,000. So if you are starting a company,
Having a little internet issue, Henrique, with your Wi-Fi there. You're frozen. Oh, looks like we're going to need to take a minute for Henrique to get back online here. All right, he's on mute. He'll take himself off mute in a second.
Okay.
Be able to reconnect. And then Enrique, I'm going to turn it over to Abby, and she'll be driving from here to help you.
Okay, thank you.
Okay.
Let me know,
all right,
let me know if you can now see my screen again.
Yep, looks great.
Okay. Yeah, switch to the local Wi-Fi, see if it's better versus my phone. I apologize for that. So I don't know what was like the last piece that you could hear before, like my screen froze. But like I mentioned, like the first piece, which is like all the advancement in GPU cards and all those cards, all those technologies and hardware that enable you to do some of those like faster and computations and larger models. But also there's like the I would say kind of like the easiest path, like especially if you're trying to bring like a minimum viable product or prototype to life, which is leveraging some of like the cloud solutions like Google Cloud, Microsoft Azure, and Amazon Web Services. And in any of like those cloud providers, if you wanted to do like computations with like very large models, you would easily have access to instances where you can add GPUs to your account. They might be a little bit more expensive than some of the instances that you would run if you were only using CPU. But you can go and you can spin them up and train your model, create whatever solution you want to create, and then kill them when the process is done. You have your model. You don't need to have that GPU running like forever, such that it's not very expensive to you. And also towards the end of the presentation, I'll talk a little bit about how you can get like credits and some of the other startup programs that those cloud providers have available. So I talk about data, we talk about hardware, and then there is the last piece, the algorithms, like the algorithms for like machine learning. So like, as I mentioned before, like machine learning is mainly splitting through like three major spaces. So there's what you call unsupervised learning, supervised learning, reinforcement learning. So some of them like in supervised learning and supervised learning, they have some like other splits. And here you can see on the screen a few other examples on the types of problems that you can solve with this type of technology. So for instance, if you wanted to do customer segmentation, you have methodologies with the clustering that allow you to do that. If you wanted to do recommender systems, or if you wanted to do detect like fraud, classify images, forecasting the weather or forecasting demand, there's like several solutions or several algorithms in this space, in this I would say subfamily of like machine learning that would allow you to go and create a model that would like I would say like meet the needs and meet the specifications and the requirements for the type of product that you're trying to build. We'll go into the detail for every one of them, If you have questions anytime, feel free to stop me. Feel free to pause like my presentation. Also, as you are thinking about like your pitch deck and your business canvas, try to think about some of the problems that you want to solve, and it might match to some of the methodologies that I'm talking about, or like the opposite as well. Like maybe there's like something that I'm presenting on those methodologies that might interest you, and you see that you can like pivot from some of the things that you're doing right now. Feel free like to stop me and ask questions as well. This is like supposed to be a dialogue. Like the first part was like really like the intro on some of the basics, but like any questions you have, comments or things that you have seen before that you'd like to share, feel free to pause me anytime. Any questions up to now? Okay. So this is what we'll talk like about like the first methodology. So remember, there's unsupervised, supervised, and reinforcement. So the first one is called like unsupervised learning. So the reason why it's called unsupervised is because there's no label associated with this data. So let's say you have like a lot of data associated, let's say you have like attributes like age, gender, marital status, number of children, city, car owned, etc. And you have like all this data. So there's like no label associated with that, but there's like a given task that you want to do with this data. So in this unsupervised learning space, there's typically two flavors. So one of them is what is called dimensionality reduction. And as the name says, let's say you have a bunch of dimensions, let's say thousands of attributes like the ones that I mentioned before, and you want to reduce to something like 2 dimensions on 3 dimensions because you want to be better able to visualize your data. Because, you know, we're humans, we're limited. It's really hard for us to visualize things in more than 3 dimensions. Maybe like with like 4D if we have like time, but like more than 3 dimensions becomes like really hard for us like to understand. And then the second one is a methodology called clustering. So you have, let's say for the same type of data set, like the age, gender, marital status, number of children, city, car owned, etc. And you want to be able to do like customer segmentation and create like groups of like what are like the customer groups or the customer segments that you have that you like, let's say, to try like new ads or try some other like new ads or some new like marketing materials. But again, there's no label associated with that. So again, those are the two flavors, and I'm going to show examples for both of them in the next couple of slides. So the first one, let's say that you were a startup. It was you had a historical stock price. You had like daily changes of the stock prices here over a period of I think like you have like about like 4 years here. So time is really not as important. Each one is like 1 day. It's kind of like the difference between the opening and the closing, the price for like a given stock. And you have a hypothesis, like maybe, you know, if you look at the correlations between some of those stocks, you might kind of have like a hedge, like you know what's going to happen in the future for like another stock. So let's say P&G stock changes price today, and maybe given that P&G might be correlated with let's say Kimberly Clark stock, given that the P&G stock changed today, but Kimberly Clark has not changed yet, maybe it means that tomorrow or like very soon, Kimberly Clark stock is going to change as well, and you can use that as like an algorithm trading strategy. So this is just one of examples. So the first piece, of course, you need to understand if is there any relationship between the different company stock prices that I have here on my screen. And remember, like I'm not even showing like the labels here. So there's actually a technique in the dimensionality reduction space called locally linear embedding, and what it does is it looks at all the variations that are happening for each one of like those time series here, for each one of the stocks, which means like each one of the colors here, and trying to understand if there's any type of relationship. So here in this example, you can see that is able to capture that Chevron, Exxon, ConocoPhillips, and Valero Energy, they're like all stocks that have their variability correlated, which makes sense. And also Procter & Gamble, Kimberly Clark, which is a competitor, in Colgate, they're like all stocks that kind of like move like more or less the same way. And similarly, HP, IBM, Dow, and Cisco have like stocks that kind of like move like in the they're like correlated as well. So this is kind of like one of the methodologies that we could use that would allow you to understand the relationship between the different company stock prices. And again, dimensionality reduction is the kind of like the large umbrella. local linear embedding is just one example of the methodology that you can use here. Here at the bottom, I have these. I have like the link, so you can actually go and click and see some of like those examples. So scikit-learn is one of the Python libraries that has save like machine learning algorithms that allows you to go and just get your data and train your models right away and deploy your models right away. So such that you don't need to go and start like from scratch as you are starting like your machine learning journey. Get dimensionality reduction is the larger family. So the second one is clustering. So again, there is no label associated with this data. So here I have created like a 1,500 data points, and I said that there is like weight and height associated with like those data points. I could have like put any label here, and then you can see all of like those blobs of like data points here. Anyone that understand like how many groups do I have, which data points belong to which group, and if I have a new data point anywhere in here, to which group this data point would belong. Sure, here in this example, I have made them like with a very clear separation such that you can visualize and see, yes, I can see we have like 3 data groups here, but imagine the case where you, instead of having 1,500 data points, we have 1 trillion data points. How would you go about trying to visualize them all? It would be very challenging, especially because in real life, there's a lot of noise associated with your data points. So how would you do that in a more automated way such that you don't need to visualize it? So there are actually techniques that allow you to first identify how many data groups you have, and second, identify what are like the families of like those data groups. If you want to call this group 1, group 2, and group 3, and if any data point appears in another space here, where it belongs to. So there are several techniques that you can use for doing clustering, like this example here. One of them, one of the most simple of them all, is called k-means, where it means like they're like k like nodes, k centers, which is kind of like the mean of like the distribution. So here you can see kind of like the clear separation. So the model was trained and identified that those are like the separation lines between clusters like 1, 2, 3. But again, this can take the form of like more complex models or like more complex algorithms to solve those boundaries. But then your model, your data points can be more complex as well. And again, this is a type of technique that you can use for doing customer or consumer segmentation. So let's jump next to supervised learning. So I talk about unsupervised. Unsupervised, there is no label. So the second family of like machine learning methods is called supervised because there's a label associated with that. So those are the cases where you want to do like a regression or a classification. So like a regression is the case where you want to predict a continuous label. So you can think about cases where you have a lot of data on houses. Let's say you went and you pull a lot of data from Zillow. You have number of bedrooms, square footage, like the size of the house, neighborhood. So there's a lot of information that you have on the houses, and you want to be able to predict a model that you want to be able to create a model that predicts what should be the house price for a given house, and maybe you want to use that as like a hedge, because if you want to see, well, if my model is predicting that this house values more than the current value for this house in the market, maybe I want to buy this house and I want to use and I maybe want to do some work on the house and then sell the house for like a higher price later. So there are several things that you can do with like this type of information. Think about kind of like what Zestimate does, like for Zillow. The second one is classification. So this is like the case where you want to assign like a discrete label or a category to a given piece of data. So that can be like some of the examples that I mentioned at the beginning, where you have an image and has a dog, a cat, or a person, and you want to predict like which type of mammal appears in this image. But of course, this can take the shape of like having let's say thousands or more of potential labels. So it can be, I don't know, all the different animals or mammals you can think of, or it can take the form of like having like objects in the image as well. But it can be like more complex in the sense of not just predicting which one of them is appearing in the image, but exactly in which pixel or in which area of the image that item is appearing. And you might have like multiple items in the image as well, which is very similar to the case that I showed in the beginning, where we had an image from like a computer vision model that was running the direct feed from the Tesla car, from the Tesla camera. So the first one, just like a quick example on the, not far from like the example I mentioned before on the houses. So let's say you have a lot of data on the size of houses, and you have their house prices as well. And let's say you want to predict what should be the price for a house that is 12,500 square footage. In reality, of course, this data will have like many more dimensions. Like the neighborhood, the number of bedrooms, etc. So this is just like a simplification of this data. This is all dummy data as well. So you would go and could use like a technique called like linear regression, which would identify what's the linear relationship between those two variables. And now that I have a model for this, I really don't need the data anymore. I could even get rid of like all the data points. So whenever I wanted to know what's the expected expected price for a given house size, I would have like a model that has that has pretty much compacted or zipped all the information needed from that data. I don't need the data points anymore. The model contains all the information that I need for predicting a house price. So this is just one example. And again, you can have like multiple other like dimensions associated with the house when you predict price. The second example is classification. So for instance, like I have a lot of like data points. I have the reds and I have the blue data points here. And let's say I want to be able to predict what's the value at like a -2, x -2, and y -1, or at the 2 point, etc. How would I go about creating a model that predicts like the classes on those points, and also allows me to not need to carry those data points anymore and just predict what's the probability for being red or a blue in any of the areas in this like 2D space here. So this for this example, we can use a simple classifier like key nearest neighbors. Don't confuse with k-means. Like the k is the only thing that's common between the two methods. So this is a different methodology. This, again, supervised learning classification. And with this now, we identify what's the boundary between like those two regions for identifying what's the right class. And you can even provide probabilities. So for instance, this is kind of like a probability of like 100% that this is a red, probability 100% that this is a blue. This is kind of like a probability of like 50. So this is kind of like a neutral boundary where there's the level of uncertainty is very high and the model doesn't know if this is a blue or a red. And of course, there's a little bit like more reddish, etc. But this is an example with the data points that I had here. But you can use like similar application for predicting what you see on an image, or you can use this like to predict if you should advertise for in a given consumer segment group. There's like a bunch of like other applications that you can use with classification techniques, or even like if you had text, and let's say you had text and you want to train a model to predict if this was going to be like a positive or like a negative review, like a sentiment analysis. It's like a similar technique. It's a classification solution as well, but with text instead of like those continuous data points that we have here on the screen. And then finally, in terms of methodologies, reinforcement learning. This is a little bit more like towards the advanced side. You might have heard of like those methodologies before. So reinforcement learning is the case where different from like unsupervised. So unsupervised, there was no label. Supervised, there was a label. Reinforcement learning is the case where the system is actually trying new things and like trying like some actions, trying to see if what has worked and what has not worked so well, provide some type of reward to the system, so provide some type of like feedback, such that the model keeps improving over time. So those are the types of models that you might use for like in a model, in a robot that you want to get it to learn to navigate through a room, where like the actions could be move to the front, move to the back, move left, or move right. And based on the number of like steps that it gets to a given target or not hitting some objects, it gets some type of like feedback or some type of reward or punishment, such that like over time, that model is improved based on that feedback. And at some point, you don't need to go over this like reinforcement learning process anymore. You are able to go and apply this like model right away. Second example is like if you are doing online ads. So there's different ways where you can use these reinforcement learning models for identifying which consumer segments you should be targeting with ads. And based on like the fact, let's say if the customer has clicked, so kind of click through metrics, the customer has clicked on the ad or not, you can understand if that specific consumer segment should be exposed to your ads or not, such that you optimize your marketing spend. And in this case, of course, the reward can be like a purchase behavior, click through, a clicking behavior, etc. But this again, it's a little bit more advanced in terms of methodologies in the machine learning space. So here I have like a quick example. It is kind of like a robot that is like learning to open a door. So there's I try to advance a little bit, but so this robot is trying to open the door. What they have done is all the actions is kind of like I would say kind of like all the torque that you need to put on the different parts of this robotic arm. And the type of reward is, let's say, is the robot able to fully open the door, or how long does it take for the robot to fully open the door? And based on the type of like feedback, like if the robot is able to open the door or not, the model is training over time, and it's learning. Say an example. So as you can see in this example, the way they wanted to train this robotic arm was like to be able to open the door. And initially the robot was not doing like very well, so they changed like the model, the machine learning models, the neural network that was um, that was like used like to open for, let's say, activating all the functions for the robot to open the door. And as the robot was getting feedback from like trying to open the door like time over time and trying different actions, and start getting feedback if the robot is open the door properly. And at some point, of course, the robot learns like to open the door, I would say, properly. So again, this is like one of the applications that you can see in reinforcement learning. Okay, so I talk about the methodologies. I talk about like some of like the techniques on like machine learning and how we can use them. And I hope that several of them are like kind of like hit like close to home. And you might for the pitches and for your business canvas, you are thinking about how you can accumulate data over time, how you can I would say power like or get more insights on this data using unsupervised learning techniques, or even using the supervised learning techniques. Or if you go more to advanced side, you are going to be using like reinforcement learning techniques. But I think there's like a few other practical considerations that I want you to take away as well from this space. So the first one is there's this methodology in machine learning called transfer learning, which means that you never start like from like full zero. So sure, you have a model, there are like a few things that you need to train on your model, but you are not really starting from scratch when you are training a model. So here's kind of like a few examples. So let's say you train a model to classify images of animals and like cats, dogs, birds, etc. But now you want to be able to classify cat breeds, and of course you have a label associated with cat breeds. And then, or you have a natural language processing model that's classifying newspaper article groups in science, sports, politics, etc. But you want to be able to classify those texts, the scientific texts, into electronics, medicine, and space. How would you go there? Like, how would you do this? So let's say you train your first model, the example on classifying images for animals, had your data. So your model is pretty much split in two pieces, kind of like the generic piece of the model where it's pretty much treating the image, and heads kind of like this final part of the model, and you're getting your predictions. So if you had this first model here and you want to train like a model now to classify the cat breeds, you don't need to go and train like a full model from scratch. What you do is you reuse this first part of the model that has identified the more like coarse features of like the image, and you keep this frozen. You don't change it. It's part of your pipeline, but it's not changing. And the only thing that you're really training is just this final piece of the model. You can think about kind of this like final layer of the model before you're getting your predictions. When you do this, you need like fewer images. So when you think about like data, you don't need to collect a ton of images to have a high quality model. Like in this case, for instance, to classify cat breeds, you can get a good model with much fewer images. And the second piece is the amount of computation needed to just train this small piece of your model is like very small compared to training like a full model as well. So that's like one thing that you should definitely take into consideration. The second, the machine learning algorithm is really just a piece of the puzzle. It's not like your full solution. So the machine learning code is he's really showing kind of like in terms of proportion on if you have a machine learning solution or if you have like a machine learning product, the code, the machine learning code itself is just like a small piece, but you need several other pieces like this, the model serving infrastructure, monitoring, machine resource management, feature extraction, etc. That said, this type of infrastructure is complex. However, there's plenty of like cloud solutions or machine learning libraries that allow you to bring those solutions to life. If you are going the cloud route, several of those solutions are like very plug and play, where you can pretty much connect like all of them with minimum effort from somebody that of course understand cloud solutions. But keep in mind that the machine learning code itself is just a small piece of the puzzle. You need to look at the full picture on what is needed to power your solution. Then finally, I had mentioned in the beginning about the cloud startups programs and in general free credits. I always like my strong recommendation is only build from scratch if you're out of options. So there are plenty of solutions in AWS and Google Cloud or like Microsoft that allows you to easily train like a machine learning model or an AI model. And of course, you need to bring in your own data. So if